All right. We did talk about something like this in notes. Okay. First off, kids were asking this. Is it okay to square everything? Can you square, 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 and square and just get 4x minus 3 minus the quantity of 2 minus 2x minus 1 equals 0? Is that math? That is not. Even if, I'll have kids tell me every year, well, I got the same answer. It's mathematics, not mathemagics. Sometimes, in rare instances, you will get the same answer. Does that mean you did the work correctly? No, it doesn't mean you did the work correctly. And I do check your work, especially on your test and your quizzes. And if you do this, the squaring, and you get the right answer, are you going to receive credit? Not even partial credit. If you do on the test and you square, 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 no partial credit. So those of you that are not listening and you do that on the test, no, you're not getting any partial credit. All right, what were the steps in notes? What did I say? Isolate the radical. Does it matter which one? If they're both the same size, it doesn't matter. Which one's easier to isolate? This one, because it's already positive. So what are we going to do with these two guys? Add them over. The square root of 4x minus 3 equals positive square root of 2 minus 2x plus the 1. Does that make sense? Is that a yes? Mm-hmm. All right, remember, no willy-nilly squaring everything. Okay, now can I square both sides? Now I'll have kids get this far, square and then square and square. Can I square itty-bitty pieces like this? Yes or no? We've been talking about that since the first day of class. If I had something like this, what's 7 plus 4? And what's 11 squared? And if we distribute, we get 49 plus what? And what's 49 plus 16? You're right, not 121. Do you guys agree? Okay, so is it mathematically okay to distribute the exponent? It is not. And that same concept holds here. It doesn't matter what's on the inside. If you have a plus or minus, it is not okay to distribute the exponent. If that was multiplication, distribute away. Addition or subtraction, you're not allowed to. What do I do here? Yes?
Would it be okay if we did square root of 4x minus 3 minus square root of 2 minus 2x equals 1 instead of moving the...
Yes. I had a kid ask that same question in my morning class. What she's saying is, what if you just moved over the 1? 4x minus 3 minus the square root of 2 minus 2x times, and move over the 1 and square this piece is what you're saying, yes? Yeah. I wouldn't suggest it because it's going to end up really messy, but can it be done? Yes. So she's saying move the 1 over, leave these two radicals here, and FOIL this. First, outer, inner, last. Yes, you can. It's going to end up a little more complicated, but doable. Got it? Okay. So we try to keep it as easy as we can. This is complicated but doable. What happens here with the square root and the squared? 4x minus 3 equals. Can I distribute the exponents there? And just say that squared plus 1 squared? No, we have to do what? Bless you. I'm sorry, I didn't hear you guys. We have to do what? FOIL. All right, let's go ahead and FOIL. This is nice. What happens here when you multiply those two that have the same base? The radical drops. Okay, and then plus 1 square root of 2 minus 2x plus another 1 square root of 2 minus 2x plus what at the end? 1. All right, equals 4x minus 3. Do you think this problem is going to be on the test? Yes, I went over it on notes. We're going to see it again and again. Do you agree these two here are like terms and these two here are like terms? Okay, 4x minus 3 equals 2 plus 1 is what? 3. Take away the 2x. Now these two, now kids will say, what about that 2 and that 1? No, you can't combine those. That 1 is connected to the radical. What do I get here? Plus what? 2 squared. And I'm adding, so the radicals do not undo each other. All right, in our notes when we had the steps, usually at this point we would be solving. But do I still have a radical? What did I say in notes if you still have a radical? You have to go back to step 1, which was undo, isolate the radical. What am I going to do with the 3? Subtract it. What about the negative 2x? And what does that give me? 6x minus 6 equals 2 radical 2 minus 2x. Now, part of the isolating is getting rid of this guy as well. Question for you first. I don't think I addressed it in notes. Can you distribute that too? No, there's a radical there. Definitely not. Now, I said in notes, if it doesn't divide nicely, then don't divide it. Leave it there. If I were to leave it and square both sides, can anybody tell me why I could do it and why I don't have to FOIL? Why would I'm not going to do it this way, but why would I be able to distribute the exponent? Because they're multiplied. He's correct. If it's multiplication in there, can you distribute the exponent? Then you would get 2 squared is 4, then they would be left with 2 minus 2x, and you would distribute the 4. I prefer to divide if it goes in evenly. Does 2 divide into both of these terms nicely? Yes or no? Yes. Again, you don't have to. You could leave it there and do what I was showing you a second ago. I'm going to divide it. What does that leave me with? 3x minus 3 equals the square root of 2 minus 2x. Now this looks kind of like what we were dealing with the other day. We've isolated. How do I undo the radical? Square it. And we're back to that same concept again. They undo each other. Here, can I just distribute and call that 9x minus 9 or 9x plus 9? No, what's that process called? What do we have to do? FOIL. All right. What does that give me? 9x squared minus 9x minus 9x is what? Minus 18x, and then plus what? 9 equals 2 minus 2x. I'm going to stop here because I think I've taken you guys far enough where you can handle the rest on your own. What do you do now? Anyone? What am I going to do with get it? I want to get it equal to what? 0. So I'm going to move these two guys over, combine them to their like terms, and then factor and solve. And don't forget, these are the ones you check at the end. You plug them into the original problem before you did any moving around to see if it works. And if not, you cross that solution out and you check the other. Did anybody factor and solve? Or did anybody getting stuck on the factoring? Has anybody factored it yet that's willing to share your numbers? 3 and 3 or 9 and 1? 9x and 1x. 1 and 7 or 7 and 1? Would it make sense to do 1, 7? What are you going to get out here when you multiply? A really big number? Okay, so 7, 1. And what is this telling? My two signs are the same. The neighbor tells me they are both what? Negative 7x, negative 9x. Does it give me the negative 16 in the middle? Okay, so what are my two solutions? 9 over 7 and what? 1. And then what do you have to do with each one? Check. And I believe only one of them works. Just the one works? Sometimes they both work. Sometimes the fraction works and not the whole number. Sometimes the negative works. Sometimes it doesn't. You really, truly have to check. Yes. Thank you very much. 9 7s definitely wouldn't work, but this is 7 over 9. Thank you, Yvette. I appreciate it when you guys are paying attention. All right, questions? Yes.
Can you do number 4 next?
Mm-hmm. Before I do number 4, I want to quickly talk about 10 and 11. This is the fire alarm problem that we did in notes. How do you recognize these on the test? First off, why do kids mess these up? Because they see the radicals and they want to do what we've been doing. Isolate the radical, square both sides, and solve. How do you know this is not that problem? What was that? The radicals are different. Those little numbers there are called the index. What's this index here?
3.
And that one there? 6. If they are not the same, this is not where you isolate the radical and raise both sides to the third power, blah, blah, blah. This is where you change to exponential form. X to the 1/3 and x to the, and then you factor and solve. What's the index right there that we don't see? 2. And here? Are they the same? No, so you change it to exponential form. X to the 1/2 and x to the 1/4 and then factor. Number 2 is tricky because it's already in exponential form, but what do you notice about the exponents? If I rewrite it as an index, like a radical problem, are they going to be the same? Yes or no? Square root of 5 plus x, square root of x, are these two numbers the same, the index? All right, so is this one like the 10 and 11 that I just showed you, or is this one more like number 1? Okay, and what are you going to subtract to the other side? 5 minus root x, and then you're going to do what to both sides? Square and square, remembering not to distribute the exponent. If at all I see anybody do square, square, square on the test, no partial credit. I've warned you and have warned you, do not make that mistake. If you just say square, 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 no partial credit. And then I'll be angry while I'm grading your test. All right, are we ready for 4? All right, is this the right problem? Okay, taking a look. Definitely, there's radicals within radicals, but we can handle it. This is definitely the side I want to isolate because it's bigger, it has a double radical, and it's already isolated. What do I raise both sides to? Second power squared. What happens with this outside radical and the squared? Does it also cancel out with the inside? No. That stays square root of x. It does not, they do not undo each other, plus the 1. Yes. Equals, and then here, Can I distribute the x? Yes or no? What's the process called? What do I have to do? FOIL. This side's going to stay. Nothing's changing over here. Root x plus 1. All right, what's 1 times 1? 1 times negative root x is negative. And is this another negative root x? And at the very end, minus or plus? Plus what? Plus positive x, right? Why just x? Right, do the square roots undo each other when I have it squared? Yes? Okay, root x times root x is root x squared, which is just x. All right, like terms here, yes or no?
Yeah.
Okay, root x plus 1 equals 1 minus 2 root x plus x. All right, back to that question we had before. Usually we're solving at this point, but do we still have a radical? If we still have a radical, we have to go back to step 1. All right, now here is where my other class was messing up. They were confused with, well, what radical do I isolate? What do you notice about these two radicals? Are they both root x? Are they like terms? So do you have to isolate like one to one side and the other to the other side? No. Should you combine these to the same side? Yes. Why is that? Because they are like what? Terms. They are like terms. What's 1 root x plus 2 root x? 3 root x plus 1 equals what? 1 plus x? Yes or no? Okay, what can I, yes?
On the problem, the one on the left side is supposed to be another x.
This guy right here?
On the left side, x.
This guy right here.
X plus 1 is supposed to be x plus x.
Thank you. Okay. Thank you for catching that. Okay. So, what am I going to do next? Isolate this guy?
Yeah, move the x over.
Move the x over. And what does that give me? 3 root x equals 1. What was that? Okay, so you're saying divide both sides by 3. And even though it doesn't divide evenly, it's only a fraction. Root x equals 1/3. Yes? And then we do what to both sides? Square. X equals what? 1/9. Don't forget to check. I will come back in a second and do more. Is there a hand up? Yes.
Did you just square the 3x and then the 1 and then the smaller x?
Yes. Yes. And you'd still get 1/9, right? Yes. Good. So she's asking, what I was saying earlier by do you have to divide? No. Can you leave it? Yes. So if we squared right here, this would still be 1. What's 3 root x squared become? If we squared, guys, what would that become? 9x equals 1. And when you divide, would you still get the 1/9? Good. So yes, both ways are correct. Any questions on 4? The checking part? The square root of 1/9 plus 1/9, big square root, 1 minus the square root of 1/9. That's the original problem, yes? Square root of 9th is 1/3 plus 1/9. 1 minus the square root of 1/9 is 1/3. So far, so good? All right, I'm going to need a common denominator for both of them. This one's easier because 1 over 1 is equivalent to what? Do you guys agree? And what's 3 over 3? Take away 1 over 3. Okay, this one a little bit harder, but not hard. We multiplied top and bottom by what to get a common denominator of 9? 3, and so 3 times 1 is, so 3/9 is 3/9 equivalent to 1/3. Yes? You can thank your elementary school teachers for teaching you awesome fractions way back when. What's 3/9 plus 1/9? Anyone? 4/9. Square root of 4 over 9 is, did it work? All right, we're good? Okay, there was a problem I told you guys I would go over and never did, and so I do want to make time for it because you will be turning these in. It was worksheet number, so worksheet 3. So this was 2.3, worksheet 3, number 17. Do you guys remember me saying, oh, I'll do that with you another day? I never did. Okay, why do I want to do it? Because you will turn this in for credit. Did anybody do this one? Like Mrs. Torres said, she'll do it, but I'll finish it anyway. You did on your own? Did you use substitution? Yeah? You factor it as is. And that's perfectly fine. I've said that before. If you use substitution, great. If not, it's up to you. I'm going to use it just because I know a lot of kids here do. Would W equal the x squared minus x? Yes or no? Okay, so W squared minus 18W plus 72. Whether you did substitution or not, what did you factor it to? Minus what? Minus 6 minus 12. Does that multiply to 72 and add up to the negative 18? Yes? Okay. So let's plug the W back in. Exaggerated parentheses. And what goes in where the W used to be? What goes in where the W? X squared minus x. Did anybody get at least this far, if not further? Good. Now, there's nothing to distribute, so what am I going to do with the inner parentheses? Can I leave them? Can I leave nested parentheses? No, I'm going to drop. And then what do I try to do if possible? Factor. Sometimes you have to regroup. Do you have to regroup, or is it already in the proper grouping? It's already proper. Do you agree? All right, so then you factor away. And then you have 1, 2, 3, 4 answers. Make sense? Looking back at worksheet 6, any other questions? Like I didn't get, was it, no, sorry. Is it worksheet 6 that we were just doing? Yeah. Any questions on maybe 10 or 11 or 8 or 7 or 9? None? Anyone want to see 8? Okay. All right, I'm back on worksheet 6. Number 8, is that the one I said I would do? All right, I have a fraction, so I need a restriction. Is there a variable in the denominator? Yes? Okay, what can the denominator not equal? What can the denominator not equal? 0. Do you guys agree it cannot equal 0? Right, denominators cannot equal 0. All right, we square. X plus 7 cannot equal 0, so what can x not equal? Do you agree that negative 7 plus 7 is 0 and the square root of 0 is 0? There are a ton of different ways to approach this problem. Anyone have any suggestions? You see this on the test, what do you do? There's more than one right answer. No one's going to venture out and throw out an answer?
Move it all under one round.
Move it, okay. She said, okay, so both answers correct. One answer was put it all under one radical, and I talked about that in notes. Can you do that when it's a division problem? Yes, as well as the multiplication. And then the other comment was multiply this to the other side. Are both methods correct? If you wanted to, could you square both sides right now?
Yeah.
Yes. All right, anyone have a preference on which way I show?
Square both sides.
Right now?
Yeah.
Now, because it is a division, which works the same as multiplication, can I distribute the exponent top and bottom? Yes, so that becomes 5x over what? Equals 4. Now, could we multiply x plus 7 to the other side? Is that the same as like cross multiplying for those of you that like cross multiplying? Yes, yes it is. 5x equals what plus what? 4x plus what? And you guys can finish from there?
I hope they use the right class on that.
Maxton Phillips, yes.
Here you go, buddy. Thank you.
Sorry. What did he say? Who is he? Hmm? All right, we have time to at least talk about one more. Any of them? 10, 11, 7, 5?
Oh, 7.
Okay, which one did you say?
7.
Could you write this under one radical because it's multiplication?
Yes.
Yes, or if you wanted to, could you go straight to squaring both sides because it's multiplication?
Yes.
Yes, up to you. I'm going to write it as 1, 1, like this. And you square both sides. X squared plus 15x equals what? Oh, that's a 10. Equals 100. Subtract, factor, and solve. Got it? X squared plus 15x minus 100 equals 0. 20 times what is 100? Would the 20 and the 5 possibly work? Yes? All right, what was the other one? Number, was it 11 or 10? 11. Cube root of x plus 2 equals 3. 6 root of x like this. All right, is this one where I isolate or where I change it to exponential form? How do we know we're going to change it to exponential form? Because these two, the indexes here are different. All right, once I get it like this, I want to get everything to one side. What's bigger, 1/3 or 1/6? So that's going first. Subtract that guy over. I'm going to put the +2 at the end. Do you guys see what I did? Now, what's half of 1/3? Is it in the right form? What is my power in this problem? The 1/3 or the 1/6? How do you guys remember that? What do you do? Always the middle, or you take half of the first one. Either way it works. Minus, minus, -2 and -1. Does that work? -2, -1. X to the 1/6 minus 2 equals 0. X to the 1/6 minus 1 equals 0. Are either one of these going to be no solution? I mean, I haven't checked it. Actually, this is not one I have to check. Are either one of these one where I cross out and say no solution? No. What do I raise both sides to in each problem? This one's easy. Hold on, guys. What does this one become? 1. 2 to the 5th is 32. So what's 32 times 2? So x equals 1 and 64. Is that a definite on the test? Yes, it is. Are we good? What's your homework this weekend? Study. There is no 7. Study for the quiz. We're going to do that eventually. You can start it, but we're going to do it eventually, yes.